Hello students, I am Professor Mandar Dikshit from Electrical Engineering Department. Today we will solve problems based on mesh analysis. In mesh analysis, we have to select loops or mesh for analysis of the problem. Kirchhoff's voltage law, that is KVL, is applied to each mesh in terms of mesh currents, and we write the equations in terms of unknown mesh currents. Once the mesh currents are known, the branch currents can be easily determined. To understand this mesh analysis technique, we will solve some numericals based on this method. The first numerical I have taken is like this. By mesh analysis, find mesh currents I1, I2, I3 in the network below. So this is my network given. The mesh currents are marked in the circuit. This is I1, this is I2, and this is I3. Now by applying mesh analysis technique, we have to find out the values of I1, I2 and I3 in this problem. So let us start the problem. Let us redraw this circuit and assign the nodes to the circuit. So in the problem, I have marked nodes A, B, C, D, E, F, G and H. From the diagram, A, B, E, D, C, A is a mesh. Similarly, C, D, G, F, C is another mesh, and third mesh is D, E, H, G, D. This is my third mesh. Accordingly, we have mark the mesh currents I1, I2 and I3. Now all these currents are marked clockwise. The direction of each current is clockwise. This is for our reference or convenience. Now we will apply KVL to mesh A, B, E, D, C, A. As per sign convention, we will move from A to B, B to E, E to D, D to C and C to A. Now let us start from A to B. In A to B, the loop direction is A to B. Similarly, my loop current or mesh current is flowing from A to B. The first element during A to B is 2 volt battery. As per sign convention, according to loop direction, the first terminal appears to be positive and second terminal appears to be negative. This shows there is a drop in potential from positive terminal to negative terminal. Hence, this 2 volt battery or source will be taken as minus 2V. Then in second part, we have a 6 ohm resistor. When I1 is flowing through this 6 ohm resistor, a voltage drop will be developed across this resistor, which is because of I1 and 6 ohm resistor. Now the loop direction is A to B and my current direction is also from A to B. So both directions are same. Hence this voltage drop across 6 ohm will be considered to be negative as per sign convention, and its value will be written as minus 6 I1. Then B to E we don't have anything. Next we will move to E to D. E to D we have a 19 volt battery As per sign convention, when we move from E to D, the first terminal appearing will be negative and second terminal appearing will be positive. So, we will assume that there is a decrease in potential from negative to positive as per our sign convention. Hence, this 19 volt will be taken as plus 19 volt in the system. Moving from E to D, the first terminal appears to be 19 volt is negative and second terminal appears to be positive. So this is increase in voltage, that is from negative to positive. Hence, as per sign convention of KVL, we will write 19 volt in the equation as plus 19 volt. Next is we will move from D to C. We have a resistor of 1 ohm resistor value. Now this resistor is common to these two mesh, that is first mesh I1 current and second mesh with I2 current. Now current through 1 ohm will be considered as resultant of I1 and I2. Therefore, voltage drop across 1 ohm resistor will be due to 1 ohm and I1 minus I2 or I2 minus I1. Now how to decide the direction? The difference I1 minus I2 should be considered because we are in loop 1. Hence, I1 will be considered or assumed as higher than I2. Hence, for 1 ohm, for mesh 1 equation, we will consider current through 1 ohm is I1 minus I2. Hence, the voltage drop across 1 ohm will be minus 1 I1 minus I2. Now minus sign is because I am going as D to C. I am going as D to C. And my current I1 is also flowing from D to C. So both directions are same. Hence the sign is minus. After considering all these values, we will put them into equation. For mesh A, B, E, D, C, A, we will write down the equation. First value will be minus 2 volt. Second value will be minus 6 I1. Next it will be plus 19 volt. And next it will be minus 1 I1 minus I2. The loop completes is equal to 0. The KVL equation is proved. Sum of voltage drops and EMF sources is equal to 0 in a mesh or loop. Now simplifying the above equation, we will get minus 6 I1 minus 1 I1, that is minus 7 I1 plus I2 is equal to minus 17. This is my equation number 1. So I got one equation as minus 7 I1 plus I2 is equal to minus 17. Now let us apply KVL to mesh C, D, G, F, C. Now while moving from in the mesh C to D, we have 1 ohm resistor which is common to first loop and second loop. Now while writing down the equation of 1 ohm voltage drop, now we are in second loop. So current difference or resultant current for 1 ohm will be considered as I2 minus I1. As we are in loop 2, we assume that I2 will be greater than I1. Hence, for second equation, it will be minus 1 I2 minus I1. Again, minus sign is because loop direction is C to D and second loop current direction is also from C to D. Then, from D to G, again we have a resistor of 3 ohm which is common to mesh 2 and mesh 3. In this case also, the resultant current in 3 ohm will be I2 minus I3 because we are in loop mesh 2. So, mesh 2 current will be assumed to be higher than mesh 3 current. So, in this case also, it will be I2 minus I3. And for sign, we are moving as D to G and current direction of loop mesh 2 will be also from D to G. Hence both the direction are same. So sign assigned to this will be minus 3 I2 minus I3. So voltage drop across 3 ohm resistor in loop 2 will be minus 3 I2 minus I3. Next we move from G to F. G to F, there is a battery of 25 volt. The first terminal appears to be negative. Second terminal appears to be positive from G to F. Hence, there is increase in voltage from negative to positive. So, for this, we have to consider plus 25 volt. Then, F to C, we have one resistance of 2 ohm value. The current direction in 2 ohm resistor is from F to C, and my mesh direction is also from F to C. Hence, voltage drop across 2 ohm will be negative and it will be written as minus 2I2. Minus sign because of same direction of loop and current. 2I2 is the voltage drop across I2. Now 2 ohm is not common for any mesh, so it is minus 2I2. So we have 4 voltage drops for C, D, G, F, C. One is minus 1 I2 minus I1. Second is minus 3 I2 minus I3. Third is plus 25 volt. And fourth one is minus 2 I2. So let us write down these individual values in an equation. For mesh C, D, G, F, C, the first element is minus 1 I2 minus I1. Then minus 3 I2 minus I3. Then plus 25, and last one is minus 2I2 is equal to 0. So we have equation minus 1 I2 minus I1, minus 3 I2 minus I3, plus 25, minus 2I2 is equal to 0. Let us simplify the equation. So we get minus 1 I1 minus 6 I2 plus 3 I3 is equal to minus 25. This is my second equation of loop C, D, G, F, C. Now we will apply KVL to third loop, that is of I3. We will start from D to E. Again we have battery of 19 volt. When I am moving from D to E, first terminal appears to be plus and second terminal appears to be minus. Hence, it is drop in voltage, positive to negative. Hence, in this case, for third loop, 19 volt will be written as minus 19. For previous loop, it was written as plus 19 volt because we are moving from E to D and first terminal appears to be negative, second to be positive. In this case, it is opposite. First terminal is positive, second terminal is negative. So, the voltage is decreasing. In this case, in previous case it was increasing. In this case it is decreasing. So, minus 19. Next element is E to H. We have 1 ohm resistor. The current flowing through 1 ohm is I3. Now, mesh direction is E to H and my current direction is also E to H. So, both directions are same. Hence, voltage drop across 1 ohm resistor will be minus 1 into I3. Then H to G, no element is there. G to D, the element is 3 ohm, which is common for loop 2 and loop 3. Now voltage drop across 3 ohm will be 3 into resultant of these two current. Previously we have written minus 3 I2 minus I3 because we were in loop 2 and loop 2 current is assumed to be higher than loop 3 current. Now we are in loop 3. So this equation will change. That will be minus 3 I3 minus I2. Now minus sign is because mesh direction is or loop direction is G to D and current direction is also G to D. So both directions are same, hence minus sign. And I3 minus I2 because we are in loop 3 and loop 3 current is supposed to be higher than loop 2 current. So difference is I3 minus I2. Now for D, E, H, G, D, we got all elements voltage drops. So we will put into equation for loop D, E, G, H, D. The first element is minus 19 volt. Then next minus 3 I2, I3 minus I2. Then we have minus 1 I3 is equal to 0. Simplify the equation, we'll get, after simplifying we'll get equation plus 3 I2 minus 4 I3 is equal to 19, equation number 3. Now we have 3 loops and we have 3 equations. So by simultaneous equation or by Kramer's rule, you can solve these 3 equations and you will get the values of 3 currents. I1 will be 2.95 ampere. Now after solving, we will get I1 as 2.95 ampere, I2 as 3.65 ampere and I3 as minus 2.01 ampere. Now this negative sign of I3 indicates the assumed direction of I3 should be opposite. That is, I3 should flow anti-clockwise direction in actual case, whereas assumed direction of I3 is clockwise. So immediately after the answer, we can conclude about the directions of all currents. I1 value is positive, so hence the assumed direction is correct. I2 answer is positive, so assumed direction of I2 is also correct. And I3 is negative, so assumed direction of I3 should be actually reverse. Hence, we have found the values of I1, I2 and I3 by applying mesh analysis to the given circuit.